Hello everyone. In this video, we shall see how do we verify uh, circular time shift property of DFT. Both we shall see theoretically as well as we shall write the SciLab code to verify the property. And the statement of circular time shift property says that if there is a shift in time domain, we have x of n minus m mod n. M is the number of shift here, so we are shifting it right. We have a sequence x of n and we are shifting it right. How many times? M times. In frequency domain, this is equal to DFT of the sequence x of n, which is nothing but x of k, gets multiplied with e power minus j 2 pi by n into km, and this is also a sequence. Okay, here k is varying from 0 to n minus 1, where capital N is the number of point DFT which we are going to take, and m is a scalar, which is one number, one single number, corresponds to the number of shift here. Uh, just to take an example, say x of n is 1, 2, 3, 4. If we take DFT of this sequence, which is 4 point here, we get x of k as 10 minus 2 plus 2j minus 2 and minus 2 minus 2j. Just for the simplicity, we shall assume that m is equal to 2. In the sense, we are shifting this sequence x of n right 2 times, which is nothing but x of n minus 2 mod n, right? Mod 4 in our case. So DFT of x of n minus 2 mod 4 is equal to what happens in frequency domain? The DFT of x of n, which is nothing but x of k, gets multiplied with e power minus j 2 pi by 4 into k into 2. So k into 2. So here 2 times 2 is 4. 4 by 4 cancels out. We end up with e power minus j pi into k. Now e power minus j pi into k can be written as e power minus j pi whole power k. And since we know that e power minus j pi is minus 1, so I can write it as minus 1 power k. So instead of writing e power minus j pi k, we shall write it as minus 1 power k. This remains as it is. Okay. Now since k takes the value starting from 0 to n minus 1, in our case n is 4. So when k equal to 0, minus 1 power 0 is 1. 1 times 10 is 10. When k equal to 1, minus 1 power 1 is minus 1. Minus 1 times minus 2 plus 2j is 2 minus 2j. When k equal to 2, minus 1 square is plus 1. Plus 1 times minus 2 is minus 2. And when k is equal to 3, minus 1 power 3 is minus 1. Minus 1 times minus 1 minus 2j is 2 plus 2j. Okay, so this is what we get after multiplying x of k with this sequence. Now if I take its IDFT, what I get is actually 3 4 1 2, and this 3 4 1 2 is nothing but the sequence x of n shifted right 2 times, right? If I shift this sequence right 2 times, 2 comes here, 1 comes to the third place, and 4 3 goes to the end, right? So basically what we did was we shifted the sequence x of n in time domain right 2 times. What happens in frequency domain is x of k gets multiplied with this sequence. If I take IDFT of this sequence, what I get is actually shifted version of the sequence in time domain. Okay, so this can be actually verified through a SciLab code, which we shall do now. So to verify time shift property of DFT, this is basically circular time shift. CLC clear close. We shall read the input first. X is equal to input in a single quote, enter the message, and the message is enter the sequence x of n. Okay, so what else we shall to read? So we read x of n. We have to take DFT of x of n, which is x of k. We shall do that. Capital X is equal to FFT of small letter x, and what we need to do is we have to multiply x of k with e power minus j 2 pi by 4 into 2k. And k, what is that k here? K is nothing but it's a sequence varying from 0 to n minus 1, and n in our case is 4. So k starts from 0 and ends at 3, right? So we'll define k now. K start from 0 and ends at 3. Now I have to read the shift. So I'll take the shift in m. Since in our statement we have m, I'll put it in m itself. M is equal to input. We shall read the number of shift also. Enter number of shift. Okay. So we have this sequence, we read M also, right? Now what we shall do is we'll do it in frequency domain, and then we'll take its IDFT so that we get back this. Okay, so what I need to do is I have to multiply x of k with e power minus j 2 pi by 4 into 2k. Let us define this part of the equation first. I'll put it in W. So W is equal to e power minus percentage I into 2 into percentage I by n. And yes, we did not define what is n. We'll do that. N is actually, it start from 0 and ends at whatever the length of the input sequence we have, length of x minus 1. Okay, so n is defined now. So e power minus a 2, this is pi by n, e power minus a 2 pi by n in our case is 4 times 2k. 2 in our case is m, so we put one more bracket here into m into k. So m is defined, number of shift, k is defined, varying from 0 to not 3, actually n minus 1, right? And 2 pi is a constant and j is a constant. Okay, so I defined this part. Now I have to multiply x of k with this, and if I take IDFT of that, I get my left hand side. So I'll just directly write it as LHS is equal to IFFT of, I have to multiply x with W, and then we shall display LHS. Okay, I'll go back to console window. So it is asking me enter the sequence x of n 1 2 3 4. Number of shift is 2. So it's giving me wrong type of argument 2. It's line number 11. I'm sorry, this should be n is equal to length of x. This is basically dot star, I guess. Three, 4, 1, 2. Okay. So what do we have theoretical result? 3, 4, 1, 2, right? So 3 plus, just ignore this if you get something like this. This is nothing but minus 0.000016 times 0, 1551. This is basically 0 actually. And here also minus 0.16 times 0, 400, and so on. So if you get something like this, you just ignore this. This is actually considered as 0. So what we got here is 3, 4, 1, 2, and what we have is 3, 4, 1, 2. We verified circular time shift property of DFT. So thank you.